My name is Zvonomir. You can just call me Z. It's been my dream since 2014 to start the open source hardware organization. This is how I originally joined RISC-V. And then RISC-V really focused on instruction set, and we wanted to have a organization that actually focuses on design flow for open source ASICs and also on the actual IPs in the form of RTL, Verilog, VHDL, Chisel, any kind of hardware description language. And that's the organization that we kicked off in March last year, and slowly has grown it. So I'll just kind of and then Berkeley is one of the members as well. So I'll just give you sort of a quick introduction. I don't want to make it long. And you can bug me today here in the meeting if you have kind of any questions or kind of curious about it. So next page. Maybe I have a control. Yes. Ted already flashed the conference agenda. We'll have Adam kick it off. I'll give a brief description of who we are by showing the members. That kind of gives you one sort of projection of CHIPS Alliance. Then I'll give you a quick overview of the CHIPS Alliance organization and leadership team, which is another angle, and then active work groups that are meeting every 2 weeks, kind of a third angle. Just to remind everybody, for resources for CHIPS Alliance, check lists.chipsalliance.org for members, and obviously GitHub/CHIPS Alliance, where most of the current code resides. So what is the CHIPS Alliance? It's an open organization that developed and hosts open source hardware code, IP cores, and open source software design tools. And it's kind of interesting, when we started, we kind of focused on the IPs. And then the moment we started, the software design tools part started growing. And more members joined and started like so. So I think this is the nature of every open source project. Every open source project wants to become an open source software project. Even if you say, I'm starting an open source hardware project, you can't, like, it's just, and I think that's normal. But we do want silicon to come out of this story at the end. It should be should fit in between two fingers. We also have a lot of we have growing efforts on interconnect IP. This is another kind of attractor. People do want to work on interfaces, and they want to work on interfaces in a new way, not just standardize them as a paper document, but contribute their starting point, some sort of implementation, RTL, maybe some circuits if you have PHY. And then they want that shared between the members and start doing things this way. So Omni Extend from Western Digital and AIB from Intel are really kind of looking into that, kind of how you build things that talk to each other. It's meant to be a barrier-free environment for collaboration. It uses standard organization framework. So when you have a group of people working on a software and hardware, they meet every 2 weeks. They discuss kind of things openly and try to reach consensus through some majority voting in a group of people working on code. Obviously, somebody has to be one person, or multiple persons need to be maintainers who actually accept contributions. A legal framework is Apache v2 license. So for those of you from Berkeley, it's kind of like BSD, just a little bit more corporate friendly, I would say. Shared resources is the ultimate reason for many companies to join these efforts. Chisel is a great example of that. It's actually being used. Multiple companies, especially in China, have commercial applications. Obviously, there is a great reason, like with any other open source software project, to contribute to it, to make it better in community. Obviously, if somebody has a proprietary ASIC, well, they can still use Chisel to do that. This is kind of an interesting chart. Who are we? I probably missed a couple of members that may have joined in the last 2 weeks, but sort of you recognize some big names like Google, Alibaba, and Intel. You recognize many RISC-V companies. Many RISC-V companies have joined or are at least talking to us and contributing. We have multiple universities that have joined. München's University of Applied Sciences being one of the first. We have Berkeley, We don't have rights to show Berkeley's logo yet, so we're working on that. This is very interesting, you know. Like, yes, Berkeley is the member, but you know, like I have to get you know, a full approval for a logo. Berkeley is a big school. I think some sports teams may have abused the logo somehow. I don't really know in what context. So we have Open Road joined, and we are trying to figure out how we're going to collaborate there. Obviously, it's a very big project, 24 universities, automated design flow, all in open source. We are using Open Road in research in Western Digital. I think Open Road project is using Swerve Core from Western Digital, which is a RISC-V core, as one of their sort of design IPs in the flow. Very, very, very interesting stuff. This is how we are organized. This is really built to look very similar to RISC-V Foundation. It's not by accident. It was a friendly organization we were aware of. So we are a project inside the Linux Foundation. Linux Foundation gives us tremendous amount of support in terms of logistics for conference and meeting organizations, for legal support, and for marketing. We have a board of directors. We have a 3 committees, similar like in RISC-V. Technical committee, the leadership team, and the outreach committee. And then the work groups are basically under the technical committee. And technical committee also introduces new work groups and proposals for new work groups. Ted Marina from Western Digital is volunteering as an interim director. We are currently we have an open requisition inside CHIPS Alliance, and we are recruiting a sort of a professional executive director. And then we have an outreach committee similar like RISC-V, chaired by Michael Gilda, that works on organizing events. And if I didn't say, yeah, chair of technical committee is Henry Cook from Sci-Fi. Events, we have organized several events, including this one today, Chisel workshop. We are working on a workshop in China together with Alibaba. Unclear exactly when it's going to be. I don't even know if you're going to have any impact of the coronavirus on this event. We may or may not. We failed to get government approvals for March, so we're kind of drifting maybe in April, May timeframe. Our first event was in Google in Mountain View on June 19th. And then we also had a very interesting event in Munich University of Applied Sciences focused on the design verification. There was about similar size as this event, about 40 experts focused on CocoaTB, Verilator, and discussing how you transition UVM or universal verification methodology flow, something very important to large ASIC programs in any company, how to transition that into open source. So goals and deliverables, I kind of already said this, lower the cost of development by working together on everything that can and should be in open source, like key IPs and software design tools. And really focus on the collaboration to enable some breakthrough innovation projects. And then design open source RTLs that can enable purpose-built solutions for everybody else. Work groups that are currently active are Chisel work group. Obviously, you guys have a huge community that's been very important in the RISC-V world for the last 4 or 5 years. Interconnect work group that currently hosts discussions on a TIE-Link, improvements for the TIE-Link cache coherence protocol, ABI specification that was donated by Intel, and OmniExtend, which is a TIE-Link over Ethernet protocol. Then we have a Rocket SoC that also came from Berkeley. Then we have a CORS work group that I think has their first official public meeting tomorrow. Currently, CORS work group has a Swerve, 2 generation of Swerve RISC-V cores from Western Digital. These are the superscalar dual issue 9-stage core called EH1, Swerve EH1. and then the second generation core, which is a multi-threaded version of SWR VH1. These are the sort of cores really focused on embedded applications, so they don't have your usual level 1 and level 2 cache hierarchy, but really have a tightly coupled instruction and data caches. And finally, there is a tools workgroup which also meets often and currently has a Verilator project by Wilson Snyder, Fuse SoC project by Olaf Kingren, and support for RISC-V cores, and a CocoaTB Verilator project, which is really enablement of the Python-based CocoaTB to support Verilator simulator and kind of trace one of the paths to the UVM-like methodology in open source. And last chart, please join CHIPS Alliance for everybody whose company is still not a member to contribute to the development of open source design tool software, to share the resources to lower the cost of development, and obviously to gain access to some very interesting high-quality designs, especially designs that are in progress. There's a few bits and pieces that don't get open sourced until they're fully kind of ready for as official project, but members have access to everything, including stuff that doesn't work yet, etc. So thank you very much. I'm super excited to have everybody here and to listen to the presentations. So to stay on time, Adam.
Thanks, Z. Appreciate it. All right, Adam.